Before we go through this example, please remember that we have learned about three equations: lens maker equation, thin lens equation, and also linear magnification. When are we going to use lens maker? When we are going to use thin lens? If you have the value for R1 and R2, then you can use lens maker equation. But if you don't have the value of R1 or R2, you are given maybe U, maybe focal length, then you can use thin lens equation to find the answer. Example 1.14, a thin planar convex lens. So please make sure you know what is the shape of this planar convex lens. Okay, it should be one surface is convex, one surface is flat or plane. It's made of glass of refractive index 1.66. When an object is set up 10 cm from the lens, this will be the U. A virtual image. So what does it mean by a virtual image? V is equal to negative and form same side with object. Okay, which is 10 times its size is formed. This one refer to the magnification. 10 times its size means that dia magnified 10 kali ganda. So M is equal to 10. Determine the focal length of the lens and the radius of curvature of the convex surface R1. Okay, so if you want to solve for the focal length of the lens using lens maker equation, so we have 1 over F equal to N2 over N1 minus 1 times with 1 over R1 plus 1 over R2. I'm using the first method, okay? So if you want to use this equation, lens maker equation, to solve for focal length, so we actually does not have the radius of curvature for both surface. So let's say the shape of the lens is like this. And this is R1, this is R2. R2 for sure we know that it will be infinity. But R1, we don't have the value. So let's skip this equation. Try to use thin lens equation. 1 over F equal to 1 over U plus 1 over V. So U is 10 cm. V right here, you actually can get from the magnification equation. M equal to negative V over U. So M is 10. Negative V is what we are looking for. And U is 10. So V will be equal to negative 100 cm. So put negative 100 cm right here. Then you will get the focal length equal to positive 11.11 cm. So positive focal length refers to this is convex lens. So it's proof that we use this planar convex lens. So you should get positive value of F. So this is the answer for question A. For question B, we need to find the radius of curvature of the convex surface R1. Now we can use the lens maker equation. So 1 over F, F is positive 11.11 equal to N2. N2 is the this refractive index of this medium. So it should be 1.66 divided with N1, this medium, which is R. Sebab soalan tak cakap pun dia dekat dalam air ke, dekat dalam oil ke, dekat any other material. So kalau tak ada mention apa-apa, the thin lens will be in air. So this one will be 1.0 minus 1 times with 1 over R1 plus with 1 over R2, which is infinity. So this is the equation. 1 over focal length, N2 divided with N1 minus 1 times with 1 over R1 plus 1 over infinity. When you want to substitute the value, please make sure that you know the shape of the thin lens. Now let's calculate for R1. So this one is 0.09 equal to, this one is 0.66 times with 1 over R1 plus with 0. Alright, so this one bring to this side. So 1 over R1 will be equal to, this one is 0.136. Then we get R1 equal to 7.33 centimeter. So for this thin planar convex, R1 radius of curvature for the first surface is 7.33 centimeter, and the radius of curvature for the second surface is infinity. So this is the answer. Next, example 1.15. An object of height 3 cm is placed 25 cm from a diverging lens of focal length 50 cm. Calculate the position of the image, V. What is the linear magnification, M. And the final height of the image, HI. State the characteristics of the image. Alright, so this is the height object, 3 cm. 25 cm is U. Diverging lens, so it's concave lens. Of focal length 50 cm. So is it positive or negative? For concave lens, it will be negative 50 cm. 1 over F equal to 1 over U plus 1 over V. So F is negative 50, U is 25 cm, and 1 over V. From here, we can get V, negative 16.67 centimeter. So negative means the image is virtual and form same side with object. Okay, next, what is the linear magnification? So let's use M equal to negative V over U. So negative V is negative 16.67 divide with U, which is 25, then you will get positive 0.67. This one shows that the image is upright, and since 0.67 is less than 1, so it's diminished. Okay, one more is the final height of the image. So we can use this equation, M equal to height image divided with height object. So magnification we get from this equation, which is positive 0.67, and then height of the image divided with height of the object, which is 3 cm, then we will get 2.01 cm. This is the height of the image. Now for question C, state the characteristics of the image. We can refer to all these answers. First, the image is virtual, form same side with the object, upright, and diminish. That's easy, kan? Now, let's proceed to the next question. Example 1.16. A thin lens is made from a material with refractive index 1.52. The radius of curvature for surface P and Q are 30 cm and 60 cm respectively, as shown in figure below. So this figure shows this is convex meniscus with two surfaces. So the first one is P with radius of curvature R1 equal to 30 cm. So we are going to decide whether it's positive or negative later. And this surface, second surface, is surface Q, or we can say as R2 equal to 60 cm. So if I want to use method 1, I'm going to look at this surface first from this side. So our eyes will be at this side. So this side is convex surface, so it will be positive. And then for the second surface, I'm going to look from this side to this surface, so it's concave to your eyes, so negative. Alright, so the question asks to find the focal length if the lens is placed in air. So air, N will be equal to 1.0. And second situation is when we put it in water with n equal to 1.33. Okay, let's do the first one first. So for question A, write the equation first. Let's make an equation. 1 over f equal to n2 over n1 minus 1 times with 1 over r1 plus 1 over r2. So n2 is this medium, 1.52, n1 is 1.0, minus 1 times with 1 over r1 positive 30 plus 1 over r2 which is negative 60. So you will get focal length equal to 115.38 centimeter. This is for question A. For question B, we're going to use the same equation, but we're going to replace n1 with water. Okay, because this lens is being put in the water. So n2 will be 1.52, n1 is 1.33 minus 1 times with okay, so F will be equal to 420 centimeter.